All right, if there was one lesson in this chapter that was easier than the others, it would probably be this one, simply because, in a way, you've already done this type of lesson when we solved equations earlier in the year. We don't have to do any graphing, we don't have to do any big new tricks. We're simply going to be solving using the reverse order of operations, like we did at the very beginning. So, quick note, a couple of quick notes to begin with. Number one, when we solve quadratics using square roots, we have three possibilities. We can have one solution, which is pretty rare. We saw that when we did the last lesson, lesson 4. We most of the time will have two solutions, and you can see why we would have two solutions the majority of the time from what we did in lesson 4. And then again, it's possible to have zero or no real solutions. Okay? And again, if we were thinking of this graphically, it would look, something like that. If we graphed it, it would never touch the x-axis. If we graphed it with two solutions, it would touch it in two spots. And if we graphed it and had one solution, it would touch it in precisely that one spot. Okay? Now the method that we're about to show you, when would we use this method, or when could we use this method? Well, we could really anytime. Okay, so it would work for anything, but when would I choose to use this method? There's only a select time when I would choose to use this method, and that's when I had no bx term there in the middle. Okay? I would only choose to do this for monomials or binomials. If that bx term is in the middle, that really kind of messes things up. So yeah, we're going to be solving quadratic equations today, but it's only going to be when there's no bx term in the middle. Okay, so this first set of quadratics, here you see we've got 3x squared equals 27. This is a quadratic equation. It's an equation. My degree is 2. Okay, and so I'm going to use the reverse order of operations. Exponents come before multiplication in PEMDAS, so if I'm doing the reverse, I'm going to first divide both sides by 3. That will leave me with x squared equals 9. And then, well, the inverse operation of x squared is to take the square root, hence solving with square roots. So I take the square root of both sides, and I wind up with x equals, well, what times itself equals 9? 3 and negative 3. If you forget to put negative 3, that is not just a careless error, that's a fundamental error. You'd probably either get a 2 or a 3 for that. Now, here we're moving on to part B. Again, using the reverse order of operations, I'm going to take care of subtraction before I take care of the exponent. And so here I'd be left with p squared equals 0. The square root of both sides, well, that's going to leave me with p equals, what times itself equals 0? 0. And so there is only one solution to this one. Now, over here, I'm going to be adding 3 to each side, and now I get a squared equals negative 1. I take the square root of both sides, but here's the problem. What times itself equals negative 1? Nothing. At least not any real numbers. If you take a look at the magical meme of mathematics over on the wall, you will see that square root of negative 1. Just a preview. In Algebra 2, we call the square root of negative 1 I. So if you saw square root of negative 1 over 8, that'd be like saying I over 8. Huh. Get it? Like you over 8, now you're full. Okay, so anyhow, back to work. Here we have the square root of negative 1, and since there is no number that multiplied by itself equals negative 1, we just say no real solutions. And that would be the case for any time you were trying to take the square root of a negative number. So it's not all as easy as these first few. Here we've got 2x squared minus 10 equals 6, but then it says give your answers in exact and decimal approximations. So it's a little bit more work cut out for us. We're going to first start by adding 10 to both sides. Now I'd have 2x squared equals 16. Divide both sides by 2, and so now I have x squared equals 8. So I take the square root of both sides, and so x equals, well, here's the thing. If I take the square root of 8 on my calculator, at least if it's a Texas Instrument calculator, the default will be a decimal. So 2.8, but don't forget it's also negative 2.8. But this is the decimal. I'm asking you to give me the exact answer too. So also remember that if I take the square root of 8, that's going to be the same thing as the square root of 4 times the square root of 2, which would wind up being the square root of 4 is exactly 2, that's what we call it, the exact solution, times the square root of 2. So finally, of course, this is positive and negative 2 radical 2. Okay? So this is exact. This is the approximation. Okay? And in this chapter, especially later on when I ask you to do things with the quadratic formula, I'm going to ask you to do this in both forms. Okay, last thing for lesson 5, and this actually gets us pretty close to what we're going to be doing here in the next lesson where we complete the square, because this is actually in vertex form, or completing the square form. So it's a lot closer to what we're going to do there. So here, first thing we're going to do, we have all of this times 4. So I'm going to divide both sides by 4 as my first step. These will cancel out. And I'm left with x plus 6 squared equals 8. Now, you might be tempted to subtract 6 from both sides first, but don't do that, because remember, PEMDAS, parentheses is last. Or I guess it's first. So that means it'd be the last thing that I do if I were doing the reverse order. So I'm actually going to take the square root of everything here first, and that'll take care of this, but what I'm left with is x plus 6. And over here, I've got positive, negative 2 radical 2. Well, to finish this off and actually solve for x, I'm going to subtract 6 from both sides. And now I've got x equals positive, negative 2 radical 2 minus 6. Some students want to make this like negative 4 radical 2. They'll try to combine them, but don't. This is actually the final answer. It's a little bit like saying 2x minus 6. I would never combine these to make it negative 4x. Okay? This is like that. Okay? So in exact answer, I've got 2 radical 2 minus 6 and negative 2 radical 2 minus 6. So that's my exact answer. But you know, this is good, but practically speaking, like if you had a problem-solving type question, that's not a very good answer to give. So we don't want to put it in a decimal. So we'll say 2 times the square root of 2 minus 6. Well, that's going to be negative 3.17, and then if I had the negative version, well, let's see, let's try 2, or I guess negative 2 times the square root of 2 minus 6 as well. Now I've got negative 8.8. Okay, so there we go. I want you to be able to give it to me in both forms. All right, well, believe it or not, that was your easy lesson for this chapter. Next time, we will be solving quadratic equations by completing the square.